Hey everybody, welcome. We're excited to have you at the session today. Let's kick it off by just introducing ourselves really quickly. Ads, why don't you go ahead first?
Sure, thanks, Steve. Hey, everyone. Thanks for coming, I guess, or letting me be here. My name's Ads. I'm an AI security researcher at an awesome company called Dreadnode, where I spend a bunch of time red teaming or like building offensive agents. I do a lot of bug bounty work. I originally started as a web app pen tester and then kind of ended up working at a foundation model company, which is how I kind of forked into AI, I guess. And yeah, I'm the tech lead for the OS project, which is, I guess, why we're here today. Which I'll leave that to you, Steve.
All right. Um, I'm Steve Wilson, and I am the Chief Product Officer at a company called Exabeam, where we use AI, machine learning, large language models, agents to help people improve their cybersecurity, or not really people, but large organizations. I also am the author of an O'Reilly book called The Developer's Playbook for Large Language Model Security. And as we'll get into, I am a project lead at OWASP. I founded the GenAI security project back when it was the just the OWASP top 10 for large language models, which is what we will talk about a bit today. That has since grown to amazing proportions from the first handful of us that were involved in it to, I think, 18,000 people who are involved in that organization today, which includes many of you on the webcast. So welcome. Previously, I worked at a bunch of big companies, some of which you may have heard of, like Citrix, Oracle, Sun Microsystems, going all the way back to the 90s, where I was an early member of the team that developed the Java programming language and libraries. So if you love Java, you're welcome. If you hate Java, I'm sorry. Take your pick. So let's talk about the OWASP top 10 for LLMs. This started off, the first version of it that Ads and I both worked on, as well as many others, came out kind of in the middle of 2023, so a bit more than 2 years ago now. And it was at the time one of the very first documents that really tried to pull together the different threads and the sort of minimal bits of research that had been done at the time around the security characteristics of these things. We updated it late last year, so looks like it was actually November, so almost a year ago. It was right at the end of 2024, so we called it the 2025 list. And many of the things were consistent. We kept several of the same vulnerabilities. Some of them changed names as we got to better understand them. Um, Things changed from things like what we called over-reliance in the first version of the list to simply misinformation in the next version of the list. But some things have been consistent, like prompt injection at the top of the list. But it did modify, it did re-rank, and frankly, this still feels pretty current, but a lot has happened since then. Um, this really is where we are with the 2025 list. And as you can see, we have things like prompt injection at the top, sensitive information disclosure. Really, this is about what goes in and what goes out of these models. And that really is the thing to think about. Supply chain risk is something that moved up the list dramatically when we created this latest version. I think that was very hypothetical. It was on the first list, but we've seen so many incidents of compromised models and training data on sites like Hugging Face and others. Um, uh, Going down the list, things like excessive agency, it's actually really important to look at is the idea of agency moved up some on the list. But I'd say back at the end of 2024, it was still really before the rise of the AI agent that has taken us by storm this calendar year in 2025 with so many of the agents, with so many of the models, frankly, gaining reasoning capabilities and then people building those into agents like software development agents like Cursor and Claude Code, which just have really dramatically increased their capabilities. And that does lead to the idea that the group has embarked on creating a new dedicated top 10 list for agentic applications. And so one of the things we're really trying to do is keep these things in sync. We don't want them to have the same things on them, but we're going to try and keep this list for very general uses of LLMs that may include a lot of different types of things. It's going to be a lot of very focused areas that are going to be important for agentic applications specifically. So when we do talk about what happens next, a big objective for us going into next year is to really make a coherent um, stack out of these. A couple other things about this latest version of the list. Some of the things like we added vector and embedding. RAG has become such an important topic in this space around how people use large language models that it's gotten to be really, really important. So the community didn't update this one. So just a reminder, we did change the name of the project from the top 10 list to the GenAI list. So if you want to get involved, the first place to go is go to the OWASP Slack. You can get yourself signed up for that. Then look for Project Gen AI. And there's a lot of channels there, but we do have a Gen AI project for the top 10 list specifically. It'll be easy to find once you're there. Um, but in particular, that will be a really exciting place to get involved a little bit later in the year as we really kick off the creation of the next version of that list. Obviously, within the Gen AI project, that are going exciting projects around red teaming, agentics, how hackers are using AI technology, so much stuff where you can just jump in. So when we do think about this latest version of the list that we put out in 24, 25, a fair amount of evolution. I expect to see more, especially with the division starting to happen between the Agentics list and the base list. It's a place we're going to be looking for a lot of input. So we'd love to have you join us. Um, but some of the key things that are really going on here in terms of trending is this move into reasoning models is so critical. And we were just at the tip of that. I don't think we've really addressed that, even though that kind of changes everything. The idea that we move from manual chain of thought to self-prompted chain of thought. This brings us into areas of worrying about things like memory poisoning, which is much different from when everything needed to be accrued at training time. So we see this again, exponential rise. That is not a linear scale over on that y-axis of that chart. So dramatic capabilities. And we hear people talking about the fact that in the next year or two, we're going to have people moving from hours into days and weeks that these things can stay on track. So that definitely needs to change some of our thinking. Another thing to change our thinking really is the fact that the hackers all have AI now, whether that be using dedicated technologies like creating audio and video deep fakes, whether that's using these models to do pen testing, threat research. And then the thing that we have to acknowledge is that while the big labs, the OpenAIs, the Anthropics, the Googles, they would like hackers to not be using these things. But frankly, we know at this point that there are open source models out there with no guardrails coming from countries that really are not going to put any restrictions on these things. So that's another thing that we need to keep in mind. So before I hand it over to Ads to dig into some more of the deep technical parts of the discussion, um, expect to see some announcements from us November, December, January about really kicking off this next version for the 2026 list. We're going to be looking for learnings and opinions from the last 12 months. We expect to have a first version of that new agentic top 10 list out by then. We're also always looking to bring in more data sources. So we're looking at the various databases where people are keeping track of real incidents. That should help us even more than it did last time in terms of the ranking and guidance. But expect to keep some level of consistency. We are seeing people build this top 10 list into a lot of tooling and things like that. So we're going to want to keep a certain level of consistency with this to build on the body of work that's going on in the area and the tooling that's been built on it. So with that, I'm going to wrap up here. I am going to turn it over to Ads and let him take us through the next part of the session. So Ads, over to you.
Sweet, thanks, Steve. Let me see if I can not make a fool of myself. Okay. Hopefully you can see that. Can you give me a thumbs up?
Got it.
Yeah, sweet. Thanks, buddy.
Mhm.
Cool. So yeah, I guess the bottom half of this, I'll just kind of run through some brief trends and kind of following on from Steve. So, I mean, like one thing, the LLMs are only a subset of machine learning. So a lot of people were like, "Why do you have this like top 10 list?" And it was like, well, everyone's like, in every man and his dog are like putting LLMs into APIs nowadays. So it only like theory logically made sense to do that. So therefore, obviously, the list and I guess the project kind of follow the industry because the industry is adopting and developing at such rapid pace. It's almost like we're developing these frameworks to keep up at the same time. So in terms of like the current trends, I guess like space is bigger and faster. Industry is like moving at a pace. Security can't catch up. It's like the traditional world story, but it's probably more of a springboard with AI. I would say, to be honest, just based on the impacts of outcomes and kind of the race to it. Attack surface expands. Like systems don't live in places anymore. You've got like models hosted on APIs, which can call tools, which is effectively calling functions, which is across APIs, browsers, plugins, file systems, and even networks. So some of these other like local application installs that are happening now. MCPs are a major shift towards like unanimous agent protocol. The autonomy is like really powerful, but introduces new attack paths and like reasoning models which can plan, deceive, and chain actions across multiple steps. So like multi-steps and adversarial behavior are becoming more realistic. With agentic AI, they don't just answer questions; they actually take initiatives. They're coordinating tasks, making decisions, parallelizing all that and even carry out actions with function calling with the ability to call other agents as well, right? So we're also getting like more multimodal as a de facto. Like we're no longer just dealing with text; we're taking inputs, which we're allowing uploads of files and APIs and all sorts. In terms of how's to build around this, right? So my piece of advice really is building secure systems with stochastic models. The first thing is to consider is like threat modeling. Map out the attack surfaces, map out the failing modes, look at the adversarial risks, and delineate trust boundaries. Those boundaries help you make the difference between an agent making decisions they shouldn't and it actually occurring. So plan for failure mode and what does that look like to you to prevent things like excessive agency. Adversarial resilience is key because models can always be tricked or poisoned, so they shouldn't be the first line of defense. Once deployed, the risk doesn't stop. You need continuous tracing, risk assessment, just like you with any other security tooling. And explainability and auditing are crucial. Can you look through the train of thought and the system and see why this process was called, and can you build more secure defenses around that? Adaptive policies are also a really big thing. Like protocols like OAuth, which I'll talk about in a second, aren't built for agents or like permissions such as like I can read my calendar, but I can't read Steve's. It doesn't kind of work that way with agents. So because threats evolve, tooling and security postures needs to as well. And obviously relying on red teaming, which not just relying on red teaming, but also incorporating that into your model development lifecycle, just on top of your SDLCs. One interesting, really good talk I actually watched the other day from Andre Pakoti on modern software. A lot of times people are worrying about like agents and things like that, which is totally fair. But a lot of people tend to exhaust their feelings towards it, and they're actually talking about AI in development stacks. However, from like a defender's perspective, it's not the only problem because since 2023, AI is like weaving its way into modern software's DNA, right? It's not just a feature; it now writes the production code, it now ships the production code at unprecedented speed, and it also introduces the vulnerabilities at the same time. So it accelerates innovation. Don't get me wrong, like incredibly, but also creates new security risks and a much wider attack surface. The irony is that AI is both the tool that builds the software and the threat vector security must actually defend against, which is kind of ironic but true. And it's actually kind of framed as like software 3.0, where people are actually programming in English and getting Python code or whatever in output. We're still in the 1960s of LLMs, quotes Andre, so there's massive opportunities, but really maturity as well. So MCP is like super hot, or I guess it was at the time we talked about this. An LLM can plan and reason into action, adjust its next steps. Ironically, when we actually presented similar slides in San Fran, I was talking about how we didn't have a real authorization protocol, and then I think the morning of our talk, we actually put it in, which was kind of funny but true. Just shows how quickly this stuff goes together. But what you need to know about MCP is that it's effectively an open API spec for models. So it comes with great benefits, but the amount of tools that are now spinning up is fairly incredible. So just another thing to think about supply chain and how you can safely integrate that into your software development stack. Like I said, starting with threat modeling tailored to MCP workflows, map out every tool call and data flow, where's data coming in and where's data coming out. The fundamental challenges of LLMs and why this is a problem really. What does it look like in practice? So traditional systems will separate data plane and control plane, but with LLMs, that separation is blurred. Data can become code and prompts can become logic. That's how you see things like SQL injection and text-to-SQL libraries. OAuth is brought up as a delegation mechanism, like I mentioned, but it's built for app-level delegation. So it doesn't have, it's got broad predefined scopes. Issues, the delegator is a resource owner and the recipient is a trusted client as well. And finally, because input can influence control, malicious or poorly structured input could trigger unintended behavior. There's a lot of frameworks and research which is coming out as well right now, so it's not all, I guess, doom and gloom. There's a Camel paper which is produced by Google DeepMind, which was fantastic, and effectively it kind of takes the onus. Camel actually sits outside the model, so integration is really straightforward. It integrates minimal latency, but it delivers 67% increase of effort on Agent Dojo, which was really impressive. And effectively, it's taking the more a system design approach, and I feel like this is where a lot of this stuff is kind of going forward in the future. It's actually not so just looking at the model. It's again that security abstraction of security layers to incorporate security there. Google's A2A library as well has some positive outcomes. They were looking at integrating the agent card. It embeds fine-grained role-based access control, so maybe some kind of combination of these can work for your enterprise. The great thing about Google A2A is that it actually does grade enterprise grade ORC and OFN and ORC straight off the bat. So A2A targets more the inter-agent security and interoperability. So when you've got multiple agent swarms operating together, you need to be able to identify agents and which agents can take what actions. The rise and fall of open models. Open source LLMs have revolutionized accessibility. So the point of getting it here is that anyone can take a model and fine tune it or deploy it and pull out Hugging Face nowadays, which is kind of nuts. But that has great benefits of fostering rapid experimentation, collaboration, and community-driven process. But that becomes a darker side, right? So models can easily be repurposed for malicious use, prompt injection, jailbreaking, data exfiltration, etc. And the real challenge lies in balancing the openness with meaningful guardrails. So, are you, as a security team, providing a clear path and allowing other teams to move forward safely and kind of move forward in their lanes rather than blocking them to this technology? Some of the research we did a while ago at Dreadnode, just to kind of iterate on that, is that it's actually kind of an old topic, but it just shows how simple it is to disguise a backdoor inside a model loader for a model that's hosted in a Hugging Face, and at the time was able to evade traditional security scanners. So Hugging Face supports at the time, this is like over 1.5 million. I have no idea what that number is now, but I'm sure it's very much exceeded that. There's still gaps of sophisticated security tooling, but you need to be thinking about these kind of tools that you can put in at the CI/CD pipeline layer, regular scanning, things like that. It's not just like software development, which is the software development library, which is a supply chain problem. Kind of one, I guess, wildcard that we actually had in there was system prompt leakage, which I guess are going to have mixed opinions on it. It used to be a textbook vulnerability, and it still is beneficial in some ways. Don't get me wrong, but like fast forward to 2025, we got major providers like OpenAI now let you actually explicitly serve these messages as developer messages, right? So you can inject these at runtime, which is like potentially what was a secret before is now a configurable compatibility. So it gives the attackers a new probe. Hey, what happens if I send a malformed developer message, for example, right? But I think we're moving from a static secret model to more a dynamic policy where every prompt is governed by runtime rules, telemetry, and like anomaly detection. And finally, I guess reinforcement learning. Reinforcement learning gems come from the research, the sandbox environments where agents learn by like trial and error. In a security context, we adapt this idea. Why not? It's a it's a fantastic idea. One agent plays the attacker, trying to play things like prompt injection or data poison. The other one acts as the defenders. The gym defines the task and the reward signals. So, like for example, you get +1 for blocking attack, you go -1 if it gets through. This setup lets us train models to improve policies, sanitization routines, without needing to write manual rules, right? Yeah, I guess like it enables that continuous improvement. As new threats appear, we encode them as tasks and let the defender retrain, creating like an evolving line of defense, which is another great idea for how you approach security or deploying your own models. I think that is pretty much it. Anything to add, Steve?
No, thanks for joining us, everybody, today. Really enjoyed having you. And again, if you're interested in participating on the new project to update the core OWASP top 10 for large language models, which is the underlying definitive document on the security characteristics of these strange new beasties we've been living with for the last couple of years. Ads and I would love to have you join the project. So hop on over to the OWASP Slack and join the project GenAI channels. And we'd love to have you join us on the journey.
Cool. Thanks, guys.